Hello, I'm Josh Starmer and welcome to Human Stories in AI with StatQuest and Lightning AI. In this series, we'll hear about the career journeys of passionate AI experts. From their humble beginnings to conquered challenges, we'll be inspired by the real-world experiences of professionals thriving in the ever-evolving AI landscape. Human Stories in AI is brought to you by Lightning AI. Code together, prototype, train, and deploy AI web apps, all from your browser with zero setup. Personally, I love Lightning AI because it makes it super easy to use and learn from the StatQuest coding tutorials. Just go to the webpage, click on the Run button, and bam! You get code that you can play with without downloading anything or installing any packages. Today, we have special guest Simon Stochhom, a lecturer at UCL Denmark. Simon applies machine learning, especially deep learning, to images, video, and time series in a wide variety of settings. And by wide variety, I really mean it. Simon is fearless when it comes to seizing opportunities that come up and somehow turns them all into success stories. So, without further ado, Simon, can you tell us about your journey to where you are right now at UCL? How did this all start?
Well, Josh, I think I was about 10 years old when my father, who was working as a psychologist, he came home one day with a software called Eliza. And for those who don't know Eliza is the ChatGPT of the 90s.
Oh, really?
Yeah. So it was supposed to imitate a psychologist, and it was supposed to replace psychologists, actually, by asking people questions.
Okay.
So he comes over, and I tried the software, and it says, "What's your name?" Well, I typed Simon, and it says, "Okay, Simon, tell me about yourself." And so you start saying stuff to the machine, and the machine picks up specific words and in response to it. It never gives you any answers. It just keeps asking questions.
It sounds like a good interviewer.
Yeah, exactly. And I was so fascinated about this technology that I was like, wow, I need to learn this. So I decided I wanted to program. But there was no internet back in 1990. So I went to the library and I picked up a couple of books, not on how to program, but just entire programs written. And then I just started copying them letter for letter onto the computer. And some of them worked, some of them didn't. I had no idea what I was doing. So fast forward a decade, and now I'm ready to go to university. And I decided to study linguistics, which is the study of languages. And I've forgotten all about my first love. And so while I'm studying linguistics, I come across this thing called computational linguistics. And I'm like, wow, that sounds interesting. It's how do computers understand speech? How do they speak? You know, I'm thinking, okay, I want to do that. But they don't have that course at the university I'm enrolled in, so I have to switch to a different one. So I get enrolled in the different university, and when I'm about to start, nothing really happens. I don't get any responses from the university, so I call them up, and I say, I'm enrolled in this class. Do you have a curriculum or something? And they're like, oh man, we forgot to tell you that we shut down the education after you got enrolled. I'm like, what? So they said, you can call this guy. He used to be a professor there.
Okay.
So call up the guy, and nobody answers. I called back, and they're like, oh yeah, we forgot to tell you. He got fired because of drinking.
Are you kidding me?
I'm not kidding.
No way.
So his replacement, they say, you can call the replacement. I call him up, and nobody answers. I call back to the university. Turns out he's on vacation. Okay. So they're like, okay, call his replacement. And I called the third guy, and he picks up and says, what can I do you for? And I'm like, I just want to study computational linguistics, but since you shut down the education, how am I going to do this? And he says, well, there's a different university And you can go there, and I'll just get your course credits moved to this university. So I go to that university. I study computational linguistics for a couple of years. That was my master's degree. And then one day, this guy comes into our class. This is this business guy. And he's like, does anybody in here know anything about speech recognition? Because we need somebody who does. I'm like, sure, I do. We set up a meeting, and he says, well, I'll give you half a year to build us a switchboard where you can get the person you want by speaking their name. And I'm like, I only know it theoretically. I don't know it. I mean, I can't code. I coded as a 10-year-old, but I didn't know what I was doing. I hadn't coded since. So I had no coding experience at all. But I actually get the job.
No way.
I finished the switchboard in those 6 months. Yeah.
How's that possible?
I don't know. I guess he said, if you don't finish it, I'll just fire you. So, once you get this, you're in a dilemma, or it makes you work.
So you learned how to code, and not just did you learn how to code, you learned how to code something quite complicated.
Yeah.
Where they're like,
there were libraries that you can just apply to it. So I don't know if you've heard of Dragon Speech by Nuance.
Yeah.
Those were the big guys back then.
Okay.
And those were the libraries I was using. So it wasn't that difficult, but I had to adapt it to the Danish language. There were a lot of things that Dragon Speech could not figure out about Danish. I had to type in the actual pronunciation of different words and stuff.
Oh, interesting. Like phonetically? You would type in a phonetic pronunciation.
Yes, exactly.
Okay. So that was training back then.
Yeah, it was. And so everything back then was more rule-based. It wasn't machine learning. So at this point, I still don't know anything about machine learning. I just kind of know some algorithms and I know some programming. And then the financial crisis comes, and I get fired along with the rest of the company. It almost collapses. And I've been in the company for 5 years at that point.
Okay.
So I start to indulge in teaching. I teach people with Asperger's syndrome.
Oh, okay.
And I teach them how to code, and it turns out these guys are much better than I am.
Oh, really?
Yeah. So my boss decides to give me a lot of courses. So I start taking all these certifications in coding, and I end up becoming fairly good at coding. And then I apply for a job at UCL, and that was 9 years ago. So that's where I've been ever since.
Oh, wow.
At UCL, I teach computer science for the first 4 years.
Okay.
And then I start gaining an interest in machine learning, and I come across a site called DataCamp. And DataCamp is brilliant. I mean, it's really, really good stuff, and it's free for academia. And then the next thing I come across is actually your channel. So I learned a lot from that, and I still use your videos for my students now, because now 5 years later, I'm teaching a introductory course on applied deep learning to my students, and I also come across fast AI, and that's where the coin really drops for me. I really get hooked on this, and I noticed that it's not that difficult, really. I always had this expectancy that it would be impossible to actually do machine learning. You had to be, really, really brilliant, not just an average Joe like myself. But it could be done. I would say I started out being very much hands-on, and I'm getting more and more theoretical, more and more mathematically engaged now.
So does that mean you were coming up with new architectures, or what does that mean to become more mathematical?
It means I'm starting to study the math more. I'm starting to study the algorithms more. And yes, I've actually looked at something like UNet. And I thought to myself, why are they using those skip connections? And I started testing it out, and it turns out on the data set I was trying, it actually didn't help.
Oh, really?
Yeah. And then afterwards, I found another article by some other people who had discovered the same thing.
Oh, really? Okay.
So I guess for some data sets it may work.
Yeah.
But what surprised me was the way they actually use those skip connections. They kind of just take and concatenate them. And I was like, why don't you add them together instead of concatenating? Because if you're concatenating, then you're not really looking in the image, right? You're stacking it on top of each other. So that's why I started looking at it, and that's what I mean by getting more involved into the mathematics.
Yeah, because now you're in a position where not only do you use these algorithms and you could use them, you can customize them and maybe improve them, which is pretty cool.
Yeah.
Well, cool. Would you be willing to tell us about some of the projects you're working on right now?
Sure. I have been involved in 4 different projects. The first project I was on was with I had to help a ferry company. They have to go away from using diesel engines and use electricity instead. So they
really?
Batteries. So they wanted to be able to be in the harbor for long enough that they could recharge between each trip. So I had to figure out how the different people are controlling the ship. And it turned out that in the Fast AI course I was following at that time, I noticed that you could take time series and turn them into images and then use that to identify patterns.
Can you tell us a little bit about that? You just kind of blew my mind.
Yeah.
You're taking time series, which is like, how things change over time, and you turn that into an image, and then you process it as an image?
Yeah. So what you do is you use Gramy and angular fields and Markov transition fields. And then you kind of create this colorful image.
Okay.
It doesn't look like anything, but it's just a color pattern.
Yeah.
But it represents your time series, and the Markov transition fields make sure that you kind of symbolize how much the effect is. So if the thrust is going up, then you see a different color, right? Okay. And the Gramy and angular fields represent each time step along the diagonal axis, more or less.
Okay.
So it kind of gets all this information packed in there. And then if you use convolutional neural networks, you can look for a similar pattern.
Okay.
And what happened was that I actually were able to identify who was sailing the ship only based on the amount of thrust they used.
No way.
At a given point in time.
Yeah. And not just the amount of thrust, the image of the amount of thrust over time.
Yes.
And you could figure out who is the captain.
Yeah.
That is fascinating.
That is pretty cool. Yeah, I actually wrote a couple of articles about it that have been published.
Did you come up with this technique, or is this a kind of a standard practice in the?
Well, I just saw Jeremy Howard use it.
Okay.
Going from time series to images, and I just thought, well, why not try it? Maybe it'll work here, and it did.
And forgive me, because the methods you're using to create the image, I've never heard of them, but can I ask you a question? Are there libraries that you can use that can just do this? You don't have to be an expert in this field theory thing, or what? I can't remember.
I'm not an expert in it myself. It is about using polar coordinates and then mapping them onto a regular coordinate system, really. So I'm not actually a whole lot into the math behind it, but I'm using the libraries because I've seen other people do the same.
Okay. So as fancy as it sounds, actually doing it isn't that hard, because you can just use a library to do it.
Yes.
and it works.
Yes.
That is so cool. Can I ask a few questions about the actual convolutional neural network?
Sure.
I'm just plugging a shameless self-promotion. I have a video that shows the conceptual, excuse me, it gives a conceptual explanation of how convolutional neural networks work, but I've simplified it to the most simple version you could have, so you can see all the parts, but it's not like overwhelmed with complexity. The question I have for you is, how complicated is your convolutional neural network? Because I know some of the ones that win these image classification contests are really quite, the pieces are all simple, but they just have lots of them and they just stack them. And and what did you end up doing?
I went with the simplest possible neural network I could get away with.
Okay.
So what I built was an autoencoder, really. So you have a neural network, you're taking the image and it just kind of downsize it all the way to until I couldn't downsize it anymore. And I get this latent representation, and then I train it to identify similar images, and it's very, very basic. It is convolution, max pooling, convolution, max pooling.
Okay.
As far as you can go. That's it.
And I'm almost embarrassed to ask a question about this because I'm supposed to know these things really well. That by the convolution, does that mean you're just running a filter over it?
Yes.
And what that filter does is it kind of shrinks the image a little bit.
Yeah.
And then you do this max pooling where wherever that filter matched the best, it probably has, the output is going to be a larger number than places in the image where the filter did not match. And so the max pooling sort of consolidates those high ranking places. And
Yes.
then you run the filter over it again and see if it matches, or maybe a different filter that matches things.
Yeah, and actually several filters every time.
Okay.
So you go from a 3x3 by or a 3 by let's say 28 image. My images were bigger than that, but just for sake. Then you may go to 16 by or what is it? Yeah, could be 16 by 16 by any number of filters that you want. So the number that you get the next time is actually the number of filters that you have. So you get a lot of filters, and I don't remember the exact numbers I used back then. It was, it wasn't something I put a whole lot of thought into. I was just trying to make a simple network.
Even though it was a relatively simple model, was it computationally intensive? Did you need to run it in the cloud or on?
No,
what kind of hardware were you using?
I used Google Colab.
You did it all on Google Colab?
Yes.
No way.
Yeah.
So, and I think that means you were running it on a single GPU?
Yeah.
Yeah.
Yes.
And how long would that take?
It would take a couple of hours.
Oh, okay.
So it wasn't too bad, and I think I had data for 5 years.
Oh, wow. Okay.
So, but these images are very simple.
Yeah.
And not very big.
Yeah.
They may have been 512 by 512 or something.
Okay.
So not big images, simple images. Yeah.
The other question I have is going back to sort of the original goal was I think the idea was it to figure out how long they need to stay docked to recharge.
Yes. So sometimes we knew that sometimes they only had 8 minutes and sometimes they had 17 minutes in harbor, and both of those were problems because if you only have 8 minutes, you don't have time for recharging. If you spend 17 minutes, then you're actually punishing the next guy because he has less time to do his trip.
Oh, I see.
So we wanted to make sure that everybody uses 14 minutes. So we had to figure out what patterns can we identify where this is the optimal amount of time. And that actually just led to, well, we can actually create this watch schedule.
Okay.
So shift schedule is the right word, right? So I created the shift schedule, and then we got access to the actual shift schedule afterwards, and we could kind of compare them and see if there was an overlap. And some people were easily identifiable. Others could be confused with other people.
Okay. So, what I guess what you're saying is you used a convolutional neural network to establish a shift schedule for who should be a captain when on this boat.
Or who was the captain?
Or who was, historically, going backwards.
Yes.
Yeah. And then from that, you could optimize on something, or
Yeah, well, at that time, we still didn't know what constituted a good sailing, actually, or good crossing. We still don't have any idea about it because we don't work with the project anymore.
Okay.
So we're stuck there at the current point. But you could definitely try to go into the nitty gritty and see if you could do more.
Okay. Well, still very cool that you could predict who is sailing the boat when. I think it's fantastic.
Yeah.
And you mentioned some other projects. So you said you've got about 4. So we've got 1.
Yeah. That was the first one. Yeah. So the second one is about feet. We had a case here in Denmark where people got their legs sawed off or amputated, if you will, because of bad blood flow. So apparently there's not a lot of prestige in science within legs and even less within feet. So if you don't have enough blood flow in your feet, nobody knows what to do about it, so they just amputate your leg. And it kind of became a big thing in Denmark that maybe these people shouldn't have had their legs amputated. This is actually a project that I'm starting to work on right now. So we're supposed to kind of see if we can identify the blood flow in MR scans. And so we compare different images and see if we can identify anything that can prevent you from getting your leg amputated.
That sounds like an incredibly noble effort, a noble cause. And what methods are you using? Are you using additional convolutional neural networks? Because this sounds like it's maybe image-based as well.
Yeah, it is image-based, and it will be instance segmentation is the procedure we'll go for.
What's that? Say that again.
Instance segmentation.
Segmentation.
So you create a mask of where are the muscles, where are the bones, and you just sort of identify those in an MR image, and then maybe you can, if you know where those things are, then you can also know where the blood vessels are.
Okay.
As I understand it, I'm no doctor, so.
Oh wow! How long have you been working on this one?
Just about a couple of months, and I'm still waiting for some data, so we're not that far into this project.
Is this similarly being run in Google Colab on a single GPU?
No, this will. I have a machine we call the Beast. It's actually not that crazy. It has a NVIDIA 3090 RTX graphics card. 10 gigabytes of RAM. It's way too little for most of the stuff I do, but we're trying to get a bigger machine soon. But for purposes like this, it's you can use it to test stuff off, and then we'll probably go to the cloud afterwards and see.
Okay, so you can kind of debug your algorithm and make sure it's sort of performing as expected locally, and then once you have everything ironed out, all the wrinkles, you can upload your data set and your algorithm and train it in the cloud. Excuse me.
Exactly.
Yeah.
And then the third project is one with pigs. This one came about because one of my colleagues who is in agriculture saw a magazine, and in that magazine there were some pigs in there that had been marked with angry or playful and stuff like that. And she came to the head of science at my workplace, and she said, "Can we do something like that?" And he kind of took a hold of me and he said, "Can you do this?" And I'm like, "Sure, we can do that."
Sentiment analysis for pigs.
Yes. So, but more than sentiment analysis, it was interested in, are they drinking? Are they eating? Are they lying down? Or are they standing up? Because this tells you something about the welfare of the pigs.
Okay.
So if a pig if it's drinking a lot and it's not eating, and it may be a little more tired, then it probably has diarrhea. If a pig gets diarrhea, it is contagious and everybody gets diarrhea. And then you have to use antibiotics for the entire farm. And this is what pig farmers fear the most. It's getting infections in the pigs, because then you cannot sell the meat at all. So they want to avoid this at all cost. So I had to identify these different postures. Is it drinking? Is it eating? And so on. So we did. What we did was we created this case with a Raspberry Pi in it and a Sycamore box so you could hook up 3D internet, and then a big hard disk, and we put a camera in there, and we started just recording the pigs from the ceiling of the pigsty.
Okay.
And that gave us a lot of images of pigs. And then I had a student helper who drew all the lines around and annotated all the images.
Oh, wow. Yeah, that sounds like a lot of work right there.
It is. And then I used the Tricktron 2 to begin with, which is an algorithm that Facebook has created for instance segmentation.
Okay.
It worked fine, but I switched to YOLO V8 afterwards because it's much easier to work with. It's much easier to configure, I think.
Okay. And it allows you to sort of classify the pigs in different...
Yes, while tracking them.
Yeah.
And so this is the point. If you can track that this pig has been drinking a lot, it's returning to drinking all the time, then that pig has a problem. Of course, once you go down there, you cannot see it anymore. There's no way to identify the pig. But you see it on the camera, you go down, where's the pig now?
You'd have to paint a large number on the back of each animal.
Exactly.
So you could...
Yeah. But you could track it. You could create graphs, maybe do it for the entire pigsty or something. So that project worked out pretty well. But then afterwards I was like, maybe, the drinking, eating, and laying down pigs are kind of underrepresented in the data set.
Okay.
And so I thought to myself, maybe we could do something with stable diffusion.
Okay.
Because I heard so much about stable diffusion, I had to try it.
So you can create a synthetic data set to help better train your algorithm.
Yes, exactly. So that's what I went for next, and this gave me a bit of problems. I first tried just asking stable diffusion to create pigs, but of course those pigs didn't look anything like the pigs I had.
Okay.
So I tried to use Dream Booth in a collab environment from Hugging Face. Every time it finished, it will always tell me, we can't show the pictures, we're afraid this is nudity.
Because you're showing a lot of pig skin.
Yes, pig skin looks like people's skin, so maybe this is nudity. So I never knew if my model worked.
Yeah.
So I thought to myself, all right, well, we'll try textual inversion. And textual inversion gave so-and-so results that were not too good. And so I tried going image to image. So I took one of the images, uploaded it, and kind of used ControlNet to see if I could just slightly modify it. The best results I got was if I told it to go from standing pig to sleeping pig, it would just close the eyes on the pig. And that's not how pigs sleep.
Yeah, exactly. So this is a problem.
Yeah, and it's very, very difficult to actually get it to do what you want. I mean, you can create all kinds of beautiful stuff, but to make it do exactly what you want, That's difficult.
Yeah, an art form in its own, right?
Yeah. And I tried to with control mode you can use poses. You can input a pose and an image, but there are no poses for pigs that are lying down.
Sleeping pigs, yeah.
Yeah, they don't exist. I can get a dancing man or something, but pigs don't do that. Along the way, I created some very strange looking images, mostly because the image I had kind of looks like a grill because the floor has this weird pattern.
Okay.
So when I used Stable Diffusion, it would create an image of a barbecued pig without a head, laying on the side.
Again, not super useful for training your algorithm, unless you're trying to figure out what's going on at the barbecue.
Yeah, or it would create pigs with two heads, or it would create pigs with fins, and I'm like, where do you get the fins from? If I try to reverse the prompt, you can reverse the prompt. It'll tell me a white bird flying over something. I'm like, white bird? So it seems like Stable Diffusion doesn't have a whole lot of knowledge of pigs seen from above in a pigsty.
Okay, well, noted. Maybe you can provide them with a training data set. I mean, your student graded. Maybe you could license it to them and get a lot of money, maybe for all the pig. I mean, because it's joking a little bit, but there's a lot of money to be made in this, right? Because what you're saying is it is a big problem. You don't want to have the whole a whole farm's worth of pigs go to waste or some other bad thing happen, right? There's probably a significant demand for this because pigs are one of the most popular food animals on the planet.
Uh-huh.
So joking aside, it actually sounds like a very useful and a helpful thing to get sort of advance warning that maybe there's something wrong with one of the pigs, and then we can do something about it in advance of it becoming a real big problem. Actually, it sounds very cool.
Yeah, I agree. That's, so that was the third project.
Yes.
One
more.
Yeah, the fourth project is satellite images of cloud movement. And this is something I saw Thomas Chappell do. Thomas Chappell is the guy from Weights and Biases.
Okay.
He did an article on Stable Diffusion and cloud movement. Uh-huh. And I thought that was very cool because now you can create time series indefinitely into the future. So kind of video prediction, actually.
Okay, cool. Yeah.
Yeah. And I tried that out, and I actually got hold of a company that has solar panels, and it's a huge problem to them that clouds are coming in, and they want to know 20, 30 minutes into the future how are the clouds going to be, how much sunlight is going to come through. I only did this on small scale,
okay,
but this is where I really need a supercomputer because satellite images are they're big, they're real time. I need a lot of RAM to kind of keep all that data in there.
So you need a way to scale this up to a pretty sizable sort of cloud infrastructure. Well,
yes.
It sounds very cool. Predicting cloud movement.
Yeah.
That sounds fascinating. I love it. Simon, so all four of those projects are super cool, and I'm glad we were able to cover all of them. But before we go, I was wondering if you had any advice for people that might want to be an associate professor, any lessons that you've learned during your journey that you think people could benefit from.
Sure. I'll say just do it. I mean, it sounds like Nike. But,
yeah, exactly.
But what I've come to find is that I'm just an average Joe, and I could do it. So I learned not to be afraid to just kind of do it. The guy who came into the class, I just raised my hand and said, I'll give it a shot. What's the worst thing that can happen?
That's right. 6 months.
Yeah.
Learning how to program something relatively elaborate.
Uh-huh.
I'll do it.
Yeah.
Call on me. I'll do
Yes.
it.
Yes.
And that's amazing. I mean, I would be intimidated in that context.
I'm sure I was. I'm not a very outgoing kind of person, really. I'm kind of introvert. So it's not like me to do stuff like that, but sometimes it just happens.
You just got to go for it.
Uh-huh.
And when you have the opportunity, like, it's not just about having the opportunity, it's about taking advantage of the opportunity when it comes your way. And that takes a little bit of courage and a little bit of, getting out of your comfort zone, but it can really pay off.
Yes.
That's what it sounds like it's saying to you. Like, your whole career is basically based on that.
True. Yeah.
A couple other lessons I think I learned from you are, if at first you don't succeed, try again. It's trying to get into computational linguistics sounded like such an epic journey.
True.
Like, how many? I mean, it was 3 schools later, or how many schools did you have to try until you finally got there?
Yes. I usually tell people I went to 5 different universities, all in all. So.
Yeah, exactly. I mean, that the persistence of, like, I'm just going to keep calling. I'm going to call the original professor, the backup, the backup's backup, and I'm just going to keep going down the list until I find someone. It sounds like you are a combination of persistence and just being brave and just being like, I'm going to try it. I don't know how to do it. I'm going to do what I can. It sounds intimidating, but I just have to go for it. I think those are the 2 lessons, other than the technical lessons that we learned about how you're actually getting cool things done. But maybe sort of like tips for me and living. I think those are 2 great lessons.
And follow your heart.
Yeah, follow your heart. Yeah, your passion.
Yes.
And be determined. Be stubborn. To get where you want to go. I love that. I absolutely love it. Well, Simon, I got to say, it was fantastic talking to you today. Thank you very much for being on the show, and I'm looking forward to hearing what comes next.
It was my pleasure.